Okay, so we are continuing with the from the last video. So we have the equations like d1 x1 u1 x2 is equal to b1. So the equation 1 is nothing but d1 x1 plus u1 x2 is equal to b1. Now this is my basis equation, and I want all the equations in this form only. That we will have some alpha n xn plus u n xn plus 1 is equal to beta n. So this is what we want to find out. This is my equation, basis equation, which has the form of equation number 1. So in that case, how will I define alphas and betas? So let us see. So alpha 1 is nothing but d1 and beta 1 is nothing but b1. So equation 1 has come out as alpha 1 x1 plus u1 x2 is equal to beta 1. Now equation 2 has the form of L2 x1 plus D2 x2 plus U2 x3 is equal to B3. Now I want to convert this matrix, this equation in the form of this equation. So what will I do? I will do the row operation. So what I will do, I will multiply the first equation with L2 upon alpha 1. So that will make my equation 1 as L2 x1 plus u1 L2 upon alpha 1 x2 is equal to b1 or beta 1 L2 upon alpha 2. Now do this subtract. So let us write down the equation number. So we have this as equation number, and we have this is this can be written as nth equation. So this is the equation number, and this is the equation number 2. Why we are giving it equation number 1? Because this essentially means this equation only. Now I want to convert this equation into this form. So to do that, I am doing the row operation, and I am writing down this as equation number 3. Now the instruction is that do 2 minus 3, and 2 minus 3 will lead to nothing but d2 minus L2 upon alpha 1 u1 times x2 plus u2 x3 is equal to b b b2 minus L2 upon alpha 1 times beta 1. This is my B2. So what I have done here is that I have multiplied the equation number 1, which is in the form of alpha and beta, with L2 upon alpha 2 to eliminate this element which contains L2, and to do that I have subtracted the uh, equation number 3, which comes out when we multiply equation number 1 with L2 upon alpha 1. I have subtracted this equation from the equation number 2 and I have got this equation. I will write down this again very clearly. So what I have got is that, so the equation 2 essentially came out as d2 minus L2 upon alpha 1 times u1 x2 plus u2 x3 is equal to b2 minus L2 upon alpha 1 times beta 1. Now let us write down this as alpha 2 x2 plus u2 x3 is equal to beta 2, where alpha 2 is nothing but d2 minus L2 upon alpha 1 u1, and beta 2 is nothing but b2 minus L2 upon alpha times beta 1. So we have the third equation. So this is basically this is nothing but the equation number 2. Now we have the third equation, which is L3 x2 plus d3 x3 plus u3 x4 is equal to b3. This is my equation number 3. So what I will do, mult I will do this 3 minus L3 upon alpha 2 times 2, and that will make my equation as d3 minus L3 upon alpha 2 times u2 multiplied with x3 plus u3 x4 is equal to b3 minus L3 upon alpha 2 times beta 2. So I will write down this as alpha 3 x3 plus u3 x4 is equal to beta 3. So this has become my equation number 3. So I will write down that my equation number 1 became alpha 1 x1 plus u1 x2 is equal to beta 1, where alpha 1 is equal to d1, beta 1 is equal to b1. This is my equation number 1. My equation number 2 will become alpha 2 x2 plus u2 x3 is equal to beta 2. So that will become as, where alpha 2 is nothing but d2 minus L2 upon alpha 1 times u1, and beta 2 is nothing but b2 minus L2 upon alpha 1 times beta 1. Similarly, my equation number 3 will become alpha 3 x3 plus u3 x4 is equal to beta 3. This is my equation number 3, and that will give me as alpha 3 is equal to d3 minus L3 upon alpha 2 times u2, beta 3 will be b3 minus L3 upon alpha 2 times beta 2. So the nth equation will become alpha n xn plus un xn plus 1 is equal to beta n. This is my nth equation where alpha n, or this is my alpha n is nothing but d, or let us write down this as ith equation. So this is alpha I xi ui xi bi, and this is my ith equation. So alpha ith will become di minus li upon alpha I minus 1 times ui minus 1, and beta I will be nothing but bi minus li upon alpha I minus 1 beta I minus 1. So let me give you. So this is my first equation, alpha 1 x1 plus u1 x2 is equal to beta 1, where alpha 1 is equal to t1, beta 1 is equal to b1, and then alpha I xi plus ui xi plus 1 is beta I, where I is going from 1 to n, and alpha I is given as di minus li upon alpha I minus 1 ui minus 1 beta I is nothing but bi minus li upon alpha I minus 1 beta I, and then the last equation will be alpha n xn is equal to beta n, since un is equal to 0. So the equation system is that I have alpha 1 x1 plus u1 x2 is equal to beta 1, and then alpha I xi plus ui xi plus 1 is equal to beta I. Then I have nth equation as alpha n xn is equal to beta n. So now what I can do is that I can do the back calculation, that xn will be nothing but beta n upon alpha n, and then xi will be nothing but beta I minus ui xi plus 1 upon alpha I. So this way I can calculate all the elements of vector x. So what we have done in this is that first we have converted the equations in the form of alpha and beta, and in those equational forms the last equation will have this form alpha n xn is equal to beta n. From there we can directly calculate the alpha n, sorry, we can directly calculate the xn, and if we know the xn or the last element, we can back substitute it in the previous equation and calculate the rest of the element of the vector. We'll go with an example to understand this Thomas algorithm in more detail.